All right. So here is the next question, to part B. So here z is given as an implicit function of variables x and y, and we're supposed to find partial derivatives z with respect to x and the second partial derivative. Now, if we just wanted to find the first partial derivative, then we could just use a ready formula from the lectures. But with the second partial derivative, it's probably not really that easy. So instead of just using the ready formula, so we're going to basically apply the method from the lectures that was used in the lectures to obtain to prove that, to deduce that formula. All right, so here is how we can do it. So basically we're going to look at this equation, and then we're going to differentiate it with respect to x, right? And then when we are differentiating it with respect to x, we should keep in mind that z is a function of x and y, right? So z is a function of x and y. And then we are going to differentiate the whole thing with respect to x. Okay, now x times z is the product of two functions, right? So we've got to differentiate it by the product rule. So the derivative of x with respect to x is just 1 times z plus x times the derivative of z with respect to x. Plus, now x differentiated with respect to x is just 1, so y squared. Here there is no z, minus, and here there is no x, so we've got to differentiate e to the y z with respect to x, where z is in fact a function of x, right? So this is, so we can do it by the chain rule, right? So this is going to be the exponential function y to the z times the derivative of yz, so which is y, times the derivative of z with respect to x, which is z differentiated with respect to x, plus cosine of pi y. Cosine of pi y does not depend on x, and the derivative of 4 with respect to x is just 0. Oh yeah, by the way, I forgot to do one little thing. I forgot to check that the given point is indeed on the satisfies the equation, because if it does not, then any further calculations do not make sense, and we just report that it's impossible to compute because the question doesn't make sense, right? So it's better to substitute x, y, and z, the given values of x, y, and z into the equation and check that it actually works. So xz, z is 0, so it's just 0, plus x times y squared, so this is 4, minus e to the 0 is 1, plus cosine of pi y, so y is negative 2, so this is cosine of minus 2 pi, which is 1, so plus 1 equals 4. Okay, so the equation is satisfied, so check. All right, so now this is the equation that we have, and we've got to solve for the partial derivative of z with respect to x. Well, to do it, basically we can I don't know, put the terms with z to the x together, so it's going to be x minus y e to the yz times zx, and the other two terms we can move them to the right hand side, so this is minus z plus y squared. So solving for zx, we get zx equals minus z plus y squared divided by x minus y e to the yz. And at a given point, minus 0 plus 4 divided by 1 minus plus 2 times e to the 0 is just 0, so minus 4 thirds. Okay. Now, how do we find the second partial derivative of z with respect to x? Well, basically, we just have to look at this equation again. So we've got to differentiate it one more time. Okay, So now I'm going to differentiate this equation one more time. So the derivative of z with respect to x is just zx plus, now x times zx is the product, so I've got to differentiate it by the product rule. So zx plus x times the partial derivative of zx with respect to x, so this is the second partial derivative of z with respect to x, plus y squared. So y squared does not really have any x, so minus, okay. Now y is a constant with respect to z, so we can just take it out. Okay, now we've got to differentiate whatever this is with respect to x. Now first I'm going to differentiate e to the yz with respect to x. So this is going to be y times e to the yz times z to the x, and there is one more z to the x here, right? And okay, so let me erase this. So it's negative 4/3. So let me just write it here, negative 4/3. Okay, and plus y e to the yz times zx differentiated with respect to x, right? So I'll apply the product rule here. And the partial derivative of 0 with respect to x is still 0. Okay, so now let me collect together all the terms with zxx. So I have one here and another here. So this is like x minus y squared e to the yz zxx. Okay, and the other terms should be moved to, and this one should be moved to the right hand side. So equals minus 2zx plus, oh sorry, there should be a y here. Yeah, sorry about that. Of course, no, a little error. Okay, so plus y squared times e to the yz times zx squared, right? So overall, zxx equals minus 2zx plus y squared e to the yz times zx squared divided by x minus y e to the yz. And now I can plug in the actual values. So this is minus 2 times zx is minus 4 over 3, minus 4 over 3, plus y squared is 4, I guess. E to the 0 is 1, times zx squared is 16 over 9, right? So divided by x is 1, minus y, so minus 2. Yeah, that's it. So I guess that's the answer. So if you want, you can simplify it, but this is something that I don't really need to explain, I hope.